What's numbers? Have imaginary numbers. In the review chapter, when we had a negative under a radical, we just said no real solution. But there still is a solution. There is an imaginary solution. So that's what we're going to talk about today. So we have imaginary solutions, imaginary numbers. So we can solve equations like this. X squared plus 1 equals 0. So to solve this, you subtract 1. And then you need to do the inverse of squaring, so you square root. And without imaginary numbers, you get stuck here. So we define the square root of negative 1 as I. So then we can solve these questions. So I equals the square root of negative 1. So if I is the square root of negative 1, then we can talk about what I squared is. So if you square both sides, you have I squared, and then you do negative, the square root of negative 1 squared. So the square root of negative 1 squared is square root of negative 1 squared is negative 1. So when you square a square root, you end up with just what was underneath. So negative 1 is I squared. So anytime you're solving or simplifying with I, and you see an I squared, then you need to replace it with negative 1. Okay, we're going to talk about powers of I because actually we don't leave any exponent on I. You can always rewrite it so it does not have an exponent. So these first 4 powers of I are what I want to memorize. So I to the first is I. We just talked about I squared is negative 1. So then I cubed would be negative I. Okay, here's why. So I can rewrite I cubed as I squared times I. Or even if I write out all 3. So I times I times I. All right, well, I squared is what? Okay, so you're doing negative 1 times I, which is negative I to the 4th. So if I write that 4 times, then I have I squared and I squared. So that's negative 1 times negative 1 is positive 1. And then it just cycles back through. So I to the 5th is I to the 4th times I. Well, I to the 4th is 1. And then 1 times I is I. So then it just cycles back through. So I to the 5th is I to the 6th is negative 1, I to the 7th is negative I, and then I to the 8th is 1, and so on. So it cycles back through. So you don't include exponents with I. You simplify it so it does not have an exponent. Okay, so let's talk about I to the 13th. Well, we could do it the long way and write out 13 i's. So let me show you that. 11, 12, 13. Okay. So I'm going to group these as I to the 4th because then I just am dealing with 1 and not negative 1. So I'm going to group these as I to the 4th. So here's 1. Oh. 1. 1. So 1 times 1 times 1, and then I have I left over. So I to the 13th is I. 1 times 1 times 1 times I is I. Okay, so let's figure out how I can do that faster. So thinking about this, I had these groups of 1. How many i's was that? 12. So if I would have started this as I to the 12th times I, how would I know I to the 12th would just be 1? Because it's a multiple of 4. It's a multiple of 4, and then I have 1 left over. So that's what we want to look for, are multiples of 4 without going over the exponent. So I to the 30th. You could write out 30 i's if that's what you need to do. But let's think a little bit. So what multiple of 4 is close to 30 but not over 30? 28. So I to the 28th, and then how many do I have left over? 2. So I to the 28th is 1. I squared is negative 1. So 1 times negative 1, negative 1. Questions about that? If you had a graphing calculator, there is an I button. So you are able to check that this is right. I want to see some work. I would want to see at least this written out, okay? But its second decimal point is I. Second decimal point is I. It might give your answer with some weird scientific notation, like you might see an E. So just ignore that part and look at just the beginning of it. So that will help you check. Okay? Questions about evaluating with powers of I? All right, we're going to talk about simplifying radicals now that have negatives. So we want to remember our radical rules where we can separate our factors. We can rewrite numbers and separate the factors. So I know that the square root of negative 1 is I. So that's what I want to rewrite this using. I'll rewrite negative 36 as negative 1 times 36. And then I have square root of negative 1 times square root of 36. write I6, you would write that as 6I. 6I. So that is why if you see a negative under the radical, you pull that out as I. So the negative under the radical just comes out as I. You don't need to show all these steps with the negative ones anymore, but that's why that happens. So I'm fine if you look at the square root of 36 and you just write 6I. Okay. So order of operations, you have to do parentheses first. So I'm working on the inside first. I'm just leaving this negative out here. This negative is not under a radical, so it's not an I, it's just a negative. All right, so the square root of negative 32. So I see the negative, I'm going to pull out an I. And then that'll be square root of 32. So the I comes out, that's how you get rid of that negative underneath. Square root of 32. Well, 32 is not a perfect square, but it has a perfect square factor, which is 16. 4 does go into it, but you want the bigger one. So we'll write 32 as 16 times 2. What's the square root of 16? 4. So your 4 comes out, which means you have 4I square root of 2. And now there's nothing left to do inside, so that negative is just there to greet it. So negative 4I square root of 2. All right, take a second to do the next one. You guys do the next one on your own. Okay, so your negative stays out front. The negative under the radical comes out as I. And then 25 goes into 75. The square root of 25 is 5. And you're left with 3. And then the negative greets it. So negative 5I square root of 3. So you guys got questions about that? Okay. Do a few more. So the square root of negative 144 is 12i. Yep. So you have a 2 out front. The 2 next to the radical means multiplication, so 2 times. The square root of negative 81 9i. And then because the 2 and the 9 are both outside the radical, you can multiply those. So 18i. Alright, on this third one, you can do a couple different things. You can reduce first and then separate, or you can separate and then reduce at the end. I'm going to go ahead and reduce, because negative 45 over 36, 9 goes into both of those. So it's just a fraction. What would it reduce to? Yeah, negative 5 over 4. And then I can separate my numerator and denominator to 2 radicals. Can I simplify square root of negative 5? Well, the 5 doesn't simplify, but I need to pull the negative out. You can't leave the negative under there, so pull out an I. Can you simplify square root of 4? 2. Do you have a radical left in the denominator? No, so this is simplified. So you're done here. You might sometimes see that like with variables, like if you had an x in the numerator, you could pull it to the side. So you might see this with your I out to the side. I don't care which way you leave it, but if you're checking answers, this might be something you see. Yeah. So if you separate first, like this, okay, then you'd have you'd have 3i out front, square root of 5, right, because of 9, and then over 6, and so then that gives you 2. Good question. You could do it either way. You could reduce at the beginning or at the end. Okay? All right. So now we're going to talk about complex numbers. So we're getting an idea of what imaginary numbers are. So complex numbers bring in the real and the imaginary. So sometimes there's numbers that have both parts. Okay, so a plus bi is standard form of a complex number. A is the real part, b is the imaginary part. So 7 minus 3i, that's a complex number. 7 is your real part, the negative 3 is your imaginary part. Now, if you're telling me what's imaginary and you tell me negative 3i, that's fine. You can either say negative 3 or negative 3i. Like, I don't care if you include the I. Okay. So I want to write the answer in a plus bi form and then identify a and b. So I have to simplify this first. So it is not correct to do this. Alright, you cannot cancel like that because of this subtraction sign. So when you have an addition or subtraction sign in a fraction, remember those invisible parentheses. Right now, let's focus on simplifying the numerator. So I have minus I times the square root of 8. What does 8 simplify to? Square root of 8 simplifies to? Right, 2 square root of 2. So 2i square root of 2. Now I see that I can factor out of 2. This? No. No. You can jump right from negative 8 to 2i squared root of 2. That's fine. I see now I can factor out of 2. I want to do that because then when it's out front, I can cancel the 2 in the denominator. So let's factor out of 2. So I get 8 minus I square root of 2. And then the 2's cancel. The 2's now cancel, and I'm just left with 8 minus I square root of 2. Where you put the I next to a radical doesn't matter. You put it in front or at the end. Just make sure that it's not underneath the radical. I is not underneath the radical. And so make sure if you do put it at the end, it's clear that it's not under the radical of the 2. Alright, so this is my standard form, a plus bi. So my a, my real part is 8. And my b, my imaginary part, but negative square root of 2. Again, if you put I with it, that's fine. I'm not going to count out for that, but you don't need it. You're already saying that it's imaginary. Okay? Alright, we're going to look at a few others. Just a couple more. So, negative 2, that's just a real number. That's no simplifying that you have to do. There's no radical or anything there. But we're supposed to write it in a plus bi form. So the real part is negative 2. And then what would the imaginary part be? 0, right? So plus 0i. So A is negative 2, and B is 0. So even real numbers you can write as complex numbers. Let's look at this next one. So negative 3 times the square root of negative 36, 6i, so negative 18i. So we have just an imaginary number, but you can write that as a complex number. What's the real part? 0, and then minus 18i. So this time A is 0, and B is negative 18. So if you're just given one part, a real part or an imaginary part, then the other one is 0. But you can still write it as a complex number. Okay, we're going to do one more example. So simplify the radicals first. So I know I'm going to bring an I out. What perfect square goes into 12? 4, and the square root of 4 is 2. So 2i comes out, and it was 4 times what gave you 12? 3. Okay. Now again, you cannot go right to canceling your 2 and your 4 because of that plus sign. But you need to write this in a plus bi form. You need to separate the real part and the imaginary part. You can't factor a 2 out. So the only thing you can do is separate into 2 fractions. And you have to do this because you need your real part and you need your imaginary part. So that's 7 over 4 plus 2i squared root of 3 over 4. Now you can reduce your 2 over 4. You can't do it here because you still need 7 over 4, not 7, or you can't do it here. You can't do it here because you still need 7 over 4, and if you cancel, then it would say 7 over 2, and that's not correct. So you cannot cancel. If you can't factor it out, you can't cancel until you separate. So now this becomes 7 over 4 plus I square root of 3 over 2. Again, you might see this I out to the front, especially in this case, because then it says A plus B I. I'm fine with you leaving it like this, but I know the book will write it like this with the I to the side. Alright, so my real part then, A is 7 over 4, 7/4. And my B is square root of 3 over 2. Good. Questions about that one? Okay, grab your whiteboards. That's all I notes.